Imagine a world where artificial intelligence evolves itself, creating smarter iterations with each step. A recent research paper by Microsoft explores this fascinating AI phenomenon. Since a lot of people are talking about a recent research paper from Microsoft researchers at Stanford University, it's gained some momentum on Twitter in the AI space. The paper is titled Self-Tutor Optimizer: Recursively Self-Improving Code Generation. Okay, so basically, it does exactly what it says on the tin and explores a wide range of fascinating ideas related to recursively self-improving artificial intelligence. Of course, this relates to recursively self-improving code generation, but as you can see, it does discuss how this whole process functions in the abstract. Let's take a look at some of the most important points from the paper since, well, there's actually quite a bit to talk about that you should definitely pay attention to. Recursive self-improvement is one of those buzzwords in artificial intelligence that has a lot of weight because it's very well the thing that could lead to AGI, or even ASI, artificial superintelligence. As we mentioned at the outset, they consistently referred to this issue as recursively self-improving code generation, which is motivated by but differs from a full recursively self-improving system in that the underlying language model is unaltered. This is something they say throughout the entire paper. That means that if GPT-4 were recursively improve itself, that would be completely insane because, of course, if it can do so, it will only get better. And if that does occur, then, well, we have no idea where it could go because, of course, when systems improve themselves, they can go in random directions that we weren't able to predict, which is naturally a contributing factor to the misalignment issue. In other words, the program that GPT-4 uses to produce code is evolving and getting better, while GPT-4 itself is staying the same. Thus, GPT-4 is undoubtedly a step in the right direction since over time, and whatever advice it receives on whatever assignment it receives both improve continuously. Microsoft has created a brand new system dubbed Self-Tutor Optimizer, or STOP for short. It can produce excellent code for a variety of jobs and domains and gradually get better by picking up on its own errors. This advances the development of AGI. Like us, you undoubtedly have a lot of inquiries concerning this technology. How does it function? How far can it go? Why does it matter? Don't worry, because in this video, I'll address every one of these queries and more. Here's the main reason why code optimization matters, though before we go into the specifics. It comes down to optimizing a code's performance by consuming less memory, CPU time, and network traffic. Software performs better this way, particularly when jobs need to be completed rapidly and cheaply. However, code improvement is not easy. It takes a lot of expertise to write the best code for different scenarios, and the optimal solutions may vary based on the machine and programming language. As a result, this activity frequently requires a lot of time and labor to perfect. What if this could be done automatically? Imagine a system that, in the absence of human assistance, can provide the optimal code for every given task. What if that could even learn from and improve upon its own mistakes? Microsoft has handled it this way. STOP is a new system that combines two strong concepts: Program-Aided Language Models, PAL, and Tree of Thoughts, TOT. TOT is a framework that creates immediate phases for issues in natural language solutions by utilizing huge language models. PAL is a technique that generates programs as intermediate stages for solving natural language issues using LLMs, when transfers the execution of these programs to a programmatic runtime, such as the interpreter for Python. STOP now combines these two concepts by generating program steps and natural language steps for natural language problem solving using LLMs. STOP, however, doesn't end at producing immediate stages. It contrasts to TOT or PAL. Additionally, it assesses these procedures based on a number of criteria, including accuracy, effectiveness, readability, and simplicity. STOP creates the final solution as a piece of code by choosing the optimal steps for each problem based on these assessments. Best thing, though, is this. STOP doesn't produce code only once and then stop. Additionally, it monitors and gains knowledge from its own code generation process over time. In reality, it makes use of a recursive self-improvement process that enables it to recognize and capitalize on its own advantages and disadvantages. For instance, STOP will attempt to determine why it made a mistake and how to prevent them in the future if it creates inaccurate or wasteful code for a particular issue. In a similar vein, in the event that it produces accurate and effective code for a given problem, it'll attempt to determine what went well and how to duplicate that performance in subsequent problems. Let's now explore recursive self-improvement in more detail as the mechanism behind its capacity for continuous development. This concept is not new. It exists in the broader field of artificial intelligence. However, STOP truly shines when it comes to writing code. Recursive self-improvement is all about applying what you've learned from past mistakes to create better decisions going forward. It's similar to developing the automatic habit of reviewing your work and looking for ways to improve. In this instance, it entails closely examining the code it generates, identifying areas for improvement, and adjusting the procedure to raise the bar all by itself. By doing this, the system improves the quality of the code and gets one step closer to being an autonomous system, a critical step on the path to artificial general intelligence. This self-checking and self-tweaking cycle is a foreshadowing of a day when artificial intelligence systems will continue to evolve and adapt on their own, which is significant as we strive towards increasingly intelligent and self-sufficient systems. As a result, the system becomes self-taught and capable of producing high-quality code within the need for outside input or supervision. It does this by continually improving its own generation process through experience. As fantastic as self-improving code creation seems, there must be safeguards in place to avoid unintended effects or runaway situations. Safety is the main priority in the system's design. It functions in a regulated setting to make sure that its pursuit of self-improvement doesn't spiral out of hand. Its built-in protocols watch over the code it produces to make sure it follows the required standards and work towards the desired objectives. This degree of safety assurance is essential, particularly when stepping into the realm of self-improving technology where errors might happen. STOP advances code generation with a level of responsibility that emphasizes the significance of controlled self-improvement on our path towards artificial general intelligence, all while maintaining a strong safety framework. What then can STOP's amazing abilities accomplish? A Microsoft research study claims that this technique may generate excellent code for several applications. These domains encompass a variety of fields, such as computer vision, natural language processing, mathematical reasoning, symbolic reasoning, algorithmic reasoning, data analysis, web development, and game creation. Additionally, the study shows that STOP is better at writing code than other industry-leading systems like Toddy, PAL, Codex, GPT-3, and more. This supremacy is evident in the mathematical reasoning domain in the precise, effective, simple, robust, and scalable nature of its programs. STOP uses an easy-to-understand effective method that involves the fewest number of arithmetic operations and symbol groupings. In addition, it provides a detailed explanation that is simple to understand for everyone. As a result, it not only provides accurate and timely responses, but also simple and straightforward solutions. Every solution has a breakdown, which makes it quite approachable. Furthermore, its solutions are robust and flexible, which means they can easily handle a range of inputs in unforeseen circumstances. Among STOP's numerous talents is its self-taught optimization capability. Check out the paper that is referenced in the description of the movie to see additional instances of what stopping may accomplish. To be honest, we find this technology really amazing. Really consider this. This is a system that doesn't need human oversight or instruction to produce the best code possible for every task or area. It can also recognize areas and insufficiencies in its own coding processes and make the necessary corrections after learning from them. STOP is one of the most innovative artificial intelligence systems to come around in a while, since it not only writes code, but also optimizes it without any outside input. It has the power to completely change how we develop and utilize software, as well as provide entirely new avenues for creativity and innovation. Additionally, there are certain ethical issues. An AI that is self-improving indicates that it is partially autonomous, meaning that judgments are being made without human scrutiny. It may also make unethical decisions, particularly if it puts its own advancements ahead of other factors. But what are your thoughts? Do you agree with this, or do you have any reservations or concerns? Tell me in the comment section below, and subscribe to our channel for more updates.